In this example, we're given an acceleration that's equal to 5 times t plus 4 meters per second, where t is in seconds. We are also told that at time equals 0 seconds, my velocity is equal to 5 meters per second, and my position is equal to 10 meters. And we want to find the acceleration, the velocity, and the position at time equals 6 seconds. Okay, well, let's start with our acceleration. Acceleration is equal to 5t plus 4, so at t equals 6 seconds, acceleration is equal to 5 times 6 plus 4, which equals 34 meters per second squared. So there's my acceleration at 6 seconds. Now we need to find the velocity. Well, we know that the definition of acceleration is change in velocity with respect to time, or the derivative of velocity with respect to time. So if I rearrange that, I get acceleration dt is equal to dv. But we know that the acceleration is 5t plus 4. So we'll substitute that in. 5t plus 4 dt is equal to dv. Integrating both sides, my initial condition at time 0 is that my velocity is 5 meters per second. Now I could put in here a time of 6 seconds here and velocity here and solve for it directly. However, I'm going to do this a little bit differently because I still need to find position, so I'm going to need the velocity as a function of time. So if I put this in symbolically as t here and v there, and then integrate, then I'll get velocity as a function of time, which I can use to find my position. So if I integrate this, I get 5t squared over 2 plus 4t evaluated from 0 to t is equal to v evaluated from 5 to v. Simplifying that, 5t squared over 2 plus 4t minus 0, because if I put in 0 for these, then I get 0, is equal to v minus 5. So my velocity function then becomes 5t squared over 2 plus 4t plus 5. So at time is equal to 6 seconds, my velocity is equal to 5 times 6 squared over 2 plus 4 times 6 plus 5, which equals 119 meters per second. That will be my velocity. Next, I need to figure out what my position is going to be. Well, velocity is equal to ds dt. Therefore, velocity dt is equal to ds. And substituting my velocity function that I got up here, that's a function of time, substituting that in for my velocity here, then I will get 5t squared over 2 plus 4t plus 5 dt is equal to ds. Then I can integrate both sides. Again, we can do this symbolically, so that at time 0, my position was 10 meters, and we're going to time t in position s. So then, doing the integration, 5t cubed over 6 plus 4t squared over 2 plus 5t evaluated from 0 to t is equal to s evaluated from 10 to s. And then simplifying, 5t cubed over 6 plus 2t squared plus 5t minus our equation here with t equals 0 will give us 0 equals s minus 10. Therefore, s is equal to 5t cubed over 6 plus 2t squared plus 5t plus 10. So at time equals 6 seconds, s is equal to 5 times 6 cubed over 6 plus 2 times 6 squared plus 5 times 6 plus 10, which equals 292 meters. And there is our final position at time equals 6. And that solves the problem.